All right, good everyone. Welcome back to our wonderful tutorial class. Today, we're looking at a very important question in chemistry. The question is, what is the number of moles in 3.2? That's 3.02 times 10 to the power 22 molecules of carbon dioxide. Or you can ask you, what is the amount of substance in 3.02 times 10 to the power 22 molecules of carbon dioxide? Can also come in that way. Remember, amount of substance is measured in what? Moles. So remember that. It's very, very important. So I'm going to solve this question now. So what you have to do is just to watch the video carefully. Don't distract yourself by any means. Just relax yourself. And please ensure you don't skip any part of the video. Also, subscribe to our channel in case you have not done so. And also like this video because you are going to get something from this video. I promise you that. So let's try this question and to see what we are going to have. All right, now we are going to solve this question. So what you have to do now is just to listen to the explanation. That's the major thing there. Now, there are some things you must know. There are some relations you must know as far as this calculation of amount of substance is concerned. Now, take note of the following. Remember that amount of substance is always measured in moles. And moles in this our context is not an abbreviation to the word molecules. Now, molecules is like a unit given to numbers of particles. But in the sense that numbers don't have units, it's just like a name. We'll just call it a name. Like we have also numbers of molecules in this particular compound. Now, the first relation is that the amount of substance which is in moles or the number of moles is always equal to the mass of that substance divided by the molar mass of that substance. The mass, this is the mass of the substance, while this is the molar mass. This mass is the first mass is in grams, while this molar mass is in grams per mole. Grams per mole. Grams per mole. So you take note of that. It's very, very important. Now, there is another relation that I will also call. Now, I don't know if you can still remember the quantity Avogadro's number, which is, I will denote it by Na. Let me denote it by Na. Avogadro's number is always equal to numbers of particles divided by numbers of molecules. Now, these numbers of particles is in molecules. That's what also numbers of molecules. Then this small n is in moles. This is in amount of substance. This is the amount of substance there. So remember, this was before. This n here was mass over molar mass. I hope you can still remember that. So these are the two relations we are going to be applying now for calculating the amount of substance. So making this n the solid formula, this small n. So you can say that small n is equal to numbers of particles all over Avogadro's number. Number of particles all over what? Avogadro's numbers. So from this our explanation now, we can now solve something very important now. We can now solve something very, very important. So let's try and see if we can get this answer now. So the numbers of moles, we said numbers of moles will be equal to numbers of particles divided by Avogadro's numbers. This Na. So let's look at this to see what we're going to have. Now, we said we have number of particles is always in molecules. So we have 3.02 times 10 raised to power 22. numbers of that is molecules. We have 3.02 times 10 to the power 22 molecules there. So that is that n. That is that n. Then what about Avogadro's number? Remember Avogadro's number is what? What is Avogadro's number? 6.022 approximately. Just 02 times 10 to the power what? 23. 10 to the power 23. So from here now we can have we're going to get our answer out from this place. We're going to get our answer out. So if you solve this very well, we can rewrite this upper one. If you move this point to this place, you can add 1 to this 22. That will be 23. That's if you don't want to use a if you don't want to use a calculator to do it. But if you want to use calculator to do this, there's no need of moving what's it called? There's no need of moving the point. Just type your division symbol. Just type 3.02 exponential 22 and divided by, go to the downside, you know, like 6.022 times exponential 23. So the answer you are going to have will be approximately 0.5 moles. That's what you're going to have. Approximately 0.5 moles. That would be the numbers of that would be the amount of substance in that 3.02 times 10 to the power 22 molecules of that carbon dioxide. So I hope the solution is very clear. So if I ask you now, let's quickly recall back. Let's recall back to see what we did before. We recall back to see what we did before. So if I ask you now, let me ask a question now. I ask how many what is the amount of substance? Let me ask you a question. What is the amount of substance in let's see 10 raised to the power 15? What is the amount of substance in 10 raised to the power 15? Okay, 10 raised to the power 15 is too much. It's too small. 10 raised to the power, let's say 25. 10 raised to the power 25 molecules of let's say glucose. Amount of substance in 10 raised to the power 25 molecules of glucose. So try and check if you can solve this out. Try and see if you can solve that out. So I'll give you time to solve that. All right, let's solve this now to see what we are going to have. So remember I told you the amount of substance in moles is what? Is what? Numbers of particles all over what? Avogadro's number. The number of particles here was 10 raised to the power what? 25. Divided by Avogadro's number, which is 6.022 times 10 raised to the power what? 23. So this is going to give us something very nice, which is 16.6 moles. That's what I'm going to have. This is the amount of substance here. 16.6 moles. So we are going to do other things very shortly. So you have to take note of the following. Amount of substance is numbers of moles is always equals to what? Numbers of particles over what? Avogadro's numbers. And this amount of substance, number of moles is also what? Mass over what? Molar mass. So that is two equations you are going to take note of now. Very, very important. I also take note that Na, which is Avogadro's number, is a constant number, which is approximately 6.022 times 10 raised to the power what? 23 times 10 raised to the power 23. Also take note of that. It's very, very important. It's very, very important. So this is a constant number that is equal to this. So this is constant. It's called Avogadro's constant. So take note of that. That is Avogadro's number, which is Na. So take note of this. Is very, very important. So in our next class, we'll be using this formula to unravel some mysteries and some problems. We'll be doing how to calculate concentrations and the rest, molar concentration, in mole per dm cube and grams per dm cube, grams concentration and mole concentrations and the rest. So please ensure you take note of all these formulas. Thank you.